Hi everyone. In this video I'm going to demonstrate how to run and interpret moderated multiple regression using R. Before we get started, let me note that underneath the video description you will find several links. First, you will find a link to a copy of the data which is saved in an R data file. Secondly, you will find a link to a text file containing the commands that are used in this video demonstration. Third, you'll find a link to this PowerPoint that is opened up on your screen, and then last you'll find this link right here, which is to a book that's called Doing Statistical Mediation and Moderation, and basically the examples and data are based in part from this presentation. Also, the demonstrations in this presentation are going to rely on three packages in R: the JTools package, the interactions package, and then also the lm.betas package. So you'll want to use the library function to call up all three of these packages. If you don't have them installed, you're going to need to use the install.packages function in order to install them before you can actually use them. But once they're installed, you don't have to keep reinstalling them again. You can just use the library function to call them up for future use. Now, once you've downloaded a copy of the data file and opened up the R data file and opened it up, the data you'll find is saved in a frame called mod data. So looking at this, first off, note that this variable right here is just a scratch variable, so we're not going to be using it. But the variables that we will be working with are life satisfaction, hope, grit, and negative life events. Additionally, I've got two remaining variables in the data set: negative life events.ms and grit.ms, and both of these are essentially binary variables that are created from these two variables right here. And ordinarily I would not encourage taking a continuous variable and sort of chopping it up and creating categorical variables from them, but the reason why these two binary variables are included is to demonstrate the use of moderated regression where you have predictors that are binary in nature. So for our first example, what we're going to be doing is predicting a measure of hope from negative life events in grit, and this is essentially a conceptual model where we are specifying that the relationship between negative life events and hope is being moderated by grit, and that's the reason why you have this arrow pointing from grit to the arrow that is pointing from negative life events to hope. So within this model, negative life events is being treated as the focal predictor variable, and grit is being treated as a moderating variable. So just keep in mind that the designation of focal and moderator variables is essentially a theoretical designation. It's not based on statistical grounds, and I could have just as easily specified grit as the focal predictor and negative life events as a moderating variable, but for this demonstration we're going to stick with negative life events as our focal predictor. So here I've opened up R, and what I'm going to do is a fair amount of copying and pasting from this text file that contains the commands so that I can minimize the likelihood of making errors in terms of typing in the commands and also expediting the presentation. So first off, let me just show you that once you've called up or downloaded the data file and opened it up in R, I'm just going to use the list function really quick. You can see that we have a data frame in here that's called mod data. If I use the structure function with mod data in parentheses, you can see there's the data frame that I was showing you in the PowerPoint. So next up, let's go ahead and open up our packages. So I'm going to type in library JTools inside parentheses, and then library, and make sure that you've spelled it correctly too, interactions, and then library, and then lm.beta. So now all three packages are active in memory, and so now I can use them. So once again, if you haven't already installed those packages, you're going to need to do so before you can start using them. So the first model that we're going to be running here, associated with the that first example, we're going to be regressing hope onto grit negative life events and then the interaction between those two variables. So we're going to be using the LM function, and essentially I'm going to be saving the information from, or the results from, the LM function to an object that is called fit1. So you'll see I've got fit1, and then I've got an arrow, which is just a less than sign followed by a hyphen, the LM function, and inside parenthesis we've got the name of the dependent variable, hope, tilde, then grit plus negative life events plus the interaction term. And make sure that when you are spelling these out that the names match exactly the names as they appear within your data frame. Finally, I have a comma and then a data argument set equal to mod data. So this is pointing R to the data frame to find the variables when you're running your analysis. On the next line right here, you can see I've got summary and then inside parenthesis fit1. So basically this is going to yield output for the regression model. So I'm just going to go ahead and copy these and paste these in. And so now you can see the analysis has been run. As you're looking at the results here, you can see that you've got the multiple R-square given right here. There's the adjusted R-square. You have your F statistic and p-value associated with it. You've got your unstandardized regression coefficients, just standard errors, t-values and p-values that are given. And then you can see down here you've got grit, negative life events, and the grit by negative life events interaction. So looking at the regression slope for the interaction term, you can see that it is statistically significant. You can also see that we have our regression slopes for negative life events and grit that are given. And just keep in mind that the regression slopes for grit and negative life events are essentially simple slopes. So a common misconception when it comes to looking at the effects of the individual predictors that are making up the interaction term is that the slopes are reflecting main effects, and that is actually an incorrect interpretation. The slopes are actually simple slopes, and they reflect the predictive relationship between a given predictor and the outcome when the other predictor is 0. So the slope for negative life events that we have of negative 10.692 is the predictive relationship between negative life events and hope for individuals scoring 0 on grit. And the slope for grit would be interpreted as the predictive relationship between grit and hope for individuals scoring 0 on negative life events. Now, if it's the case that a value of 0 does not appear within the range of values that are possible for grit or negative life events, then that makes interpretation of the simple slope a little bit confusing and somewhat nonsensical. So what we might want to do is to mean center our two predictor variables before we study their interaction by including them in the regression analysis. And basically when we mean center a variable, all we're doing is taking the raw score on that particular variable and subtracting the mean from it. And so essentially the newly centered variable will have a mean of 0, but the standard deviation would be the same as with the original variable. So what we're going to do is use a function associated with the JTools package in order to create new mean centered variables for negative life events and grit. And what I'm going to do right now is show you that I'm going to create a new data frame that's called mod data 2, and I'm going to be using the gscale function associated with the JTools package to create a new data frame with the newly centered predictor variables. So you can see right here we have mod data 2, that's the name of the new data frame. I have an arrow right here, then gscale. Inside the parenthesis I've got the data argument set equal to the name of the original data frame, which is mod data. Then you can see I have a comma, then VARS for variables, equals, and then I have using the C function in order to list out the variables from the mod data frame that I want to mean center. So I've got inside quotation marks negative life events, comma, then grit right here inside quotation marks, in parenthesis, then a comma, and then on the next line you can see I've got center dot only, and I'm setting that equal to true so that the newly centered variables maintain the original standard deviation. So essentially I'm trying to keep the newly centered variables from being standardized. So let's go ahead and we'll just copy this and paste it in. And now we'll look at the structure of the mod data 2 frame. So mod data 2, and so there you go. And so now as you're looking at this, you can see that we have negative life events now has positive and negative values. Remember, 0 on that variable would be the mean for the variable, and so you'd have values that are positive reflecting scores that are above the mean, and values that are negative reflecting scores that are below the mean. We also have our mean-centered grid variable as well. So now let's rerun the analysis. I'm going to create a new object called fit2, and then so everything is laid out exactly the same way as before, except that the data argument, I'm setting that equal to mod data 2. And we'll use the summary function to call up the fit2 object. So here it is. So now you can see, again, there's the interaction term, the regression slope for the interaction term. You can see it's statistically significant. And just keep in mind that that regression slope and the significance test, all that information is exactly the same as what we had above with our original variables prior to centering. The differences in terms of coefficients and so forth lie in the intercept as well as the regression slopes for our grit and negative life events variables. But in this case, now when we interpret the slopes for grit and negative life events, we would interpret them as the predicted relationship between one of the given predictors and the outcome variable for a person scoring at the mean of the other predictor variables. So in this case, with negative life events, we can say that the predictor relationship between negative life events and hope is negative 1.276 for a person scoring at the mean on grit. For the grit coefficient, we can interpret this as the predictor relationship between grit and hope for a person scoring at the mean on negative life events. Now, again, our interaction term, we found evidence for statistical significance. So next, what we want to do is to probe the interaction. So we're going to be using the interactions package and a specific function that is called probe_interaction. So you'll notice that inside parentheses, I've got fit2. You'll notice that I've got PRED for predictor set equal to negative life events. So that's our focal predictor, and then mod x is set equal to grit, so that's referring to the moderator variable. So let's go ahead and copy and paste this in, and so there are our results. So you can see first off that over here we've got a plot of the simple slopes depicting the relationship between negative life events and hope. And then over here to the left we have actually our estimates for the simple slopes. And essentially what we're doing is we're looking at the relationship between negative life events and hope at 3 different levels of grit. So the conventional approach, the conventional pick-a-point approach is plotting a simple slope at 1 standard deviation below the mean, at the mean, and at +1 standard deviations from the mean on the moderating variable. So essentially this is the point on grit which is 1 standard deviation below the mean on the centered grit variable. This is at the mean on the centered grit variable, and this is 1 standard deviation above the mean on the centered grit variable. So you can see that we have the first slope right here of negative 2.88. That would be this slope right here at -1 standard deviation from the mean on the grit variable. The slope of negative life events when grit is at the mean of the centered predictor is -1.28. So that's referring to this slope right here. So that's it right here. And then you can see we have a 0.33 which is reflecting the slope at +1 standard deviations on the grit variable. You'll notice that the slope at 1 standard deviation below the mean was significant. At the mean it was significant, but not at 1 standard deviation above the mean. And basically, if we were assuming that there was no interaction, what we would expect is for those simple slopes to be parallel to each other. Okay, one other thing that I wanted to show you before I move on to the next model is just using the lm.beta function. If you want to get standardized regression slopes, you can use that function to get them, and you can use them in conjunction with the summary function in order to have them appear in your regression table. So what I'm going to do is just I would be typing in summary, and inside parenthesis you've got the lm.beta function, and inside another set of parentheses you've got the fit2 object. So I'm going to copy this and paste it in and hit enter, and so now you can see that we have a column containing standardized regression slopes. Okay, so for our next model, we're going to add in life satisfaction as a covariate. So we're going to keep everything as is, but then add in life satisfaction. And let me also note that previously when we typed in our regression model using the linear model function, you'll notice that I typed in grit plus negative life events plus grit star negative life events. But I could actually use shorthand instead of typing in grit and negative life events. I could have just typed in grit star negative life events, and that would have produced output that would have given me again the effects of grit and negative life events, those simple slopes, plus the interaction term. But and so in this case, for this particular demonstration, I'm going to do just that. So you can see here I'm creating a new object called fit3. I've got lm inside parenthesis hope tilde grit by negative life events. So it's grit star negative life events plus life satisfaction, and then comma, then data set equal to mod data 2. And again, we'll use our summary function in order to obtain our results or to look at them. So I'm going to copy this and paste it in, and so now we have all of our information. You can see that we have the interaction term given. You can see we have evidence of significant interaction taking place, basically consistent with the notion that grit is moderating the effect of negative life event on hope. You can also see we have a positive regression slope for life satisfaction, and we have statistical significance for that. When we look at the regression slopes for negative life events and grit, again, these would be interpreted as simple slopes, basically the predictor relationship between either grit or negative life events for an individual scoring at the mean of the other predictor. And so these are the simple slopes for both of those two predictors. So if we wanted to probe the interaction, we can type in probe underscore interaction. Inside parenthesis, I've got fit3. Again, the predictor is negative life events with the moderator being grit. So let's go ahead and copy that and paste it in. And so now you can see that things look a little bit different from what we had before. So previously we had a negative relationship here at 1 standard deviation below the mean. There was also a negative relationship at the mean of grit, and then a positive relationship at +1 standard deviations from the mean on grit. In this current case, you can see that we have a negative relationship here, we have a positive relationship here, and then a positive relationship here at +1 standard deviations on grit. When we look at the simple slopes, you can see there's the negative relationship at 1 standard deviation below the mean on grit. It's statistically significant. At the mean, you can see there's a slight positive relationship, is not significant, but at +1 standard deviations from the mean, you can see it's positive and statistically significant. So you can see that by adding in the covariate in the model, our results changed a little bit. I'll also draw your attention to again the fact that the slope that is presented in the original regression table here, let's say for negative life events, which is 0.36063, and you can see it's not significant, but that simple slope is essentially the predictor relationship for an individual scoring at the mean on grit. If we go down, you can see that we get the same values that are appearing right here when we're talking about the mean of simples of grit. So there's the simple slope right there. There's our p-value. So those are exactly the same. Okay, for our third example, we are going to be looking again at grit serving as a moderator of the effect of negative life events on hope. But a couple of things. First off, we are going to leave life satisfaction in there as we had it previously. But now we're going to be using the binary grit variable. So it's actually coded 0 for low and 1 for yes. So basically right here, I'm going to create a new fit object called fit4 lm. We have hope followed by our tilde again, then grit.ms by negative life event. So this is the interaction term that we're forming, and we're leaving life satisfaction in there as our predictor variable. And then again, our data argument is set equal to mod data 2, and we'll rerun the analysis and request our summary of the model fit. So now you can see right here, this is the interaction term that's given. You can see it's statistically significant. Again, consistent with the notion that grit is moderating the effect of negative life events on hope. There's our life satisfaction predictor effect, which is 0.28. You can see it's statistically significant. So basically indicating individuals higher on life satisfaction were predicted to score higher with respect to hope. Then you've got negative life events, simple slope, and then you've also got, this is the negative life event simple slope and the grit simple slope. So with respect to the negative life events slope, we can interpret this as the predicted relationship between negative life events and hope for an individual scoring in the low grit group, which again is coded 0. Right here, this would be the predicted relationship between, this would be the difference between the low and the high grit groups for individuals scoring at the mean on negative life events. And once again, we can use the probe underscore interaction function in order to probe our interaction. But in this case, you'll notice that we've got, for the moderator variable, it's grit.ms that's being included. So I'll go ahead and copy that and paste it in. And so now you can see that we only have two simple slopes reflecting the two levels of our grit variable. So basically the low grit group and then the high grit group. So this negative slope right here is for the low grit group, and then this slope is for the high grit group. So you can see that in the low grit group, the regression slope is negative 1.64. It's significant, and this is the same value of the simple slope that we saw above in our previous regression table, and this is the positive value of the effect for the simple slope for negative life events when grit basically among the high grit group individuals. So, and you can see that slope is statistically significant. Okay, so for our final demonstration, I'm going to go ahead and include the binary grit and negative life events variables. So once again, these were formed by essentially dichotomizing the original continuous grit and negative life events variables, which I don't recommend, but once again, this is to demonstrate the inclusion of binary predictors in our moderated regression model. So we're also going to leave out the life satisfaction predictor from this model just to kind of keep things a little bit simpler. So for this analysis, we are going to create another fit object. I'm going to call it fit5. You can see right here the LM function. There's hope, tilde, grit.ms, star, negative life events .ms. And so you can see also there, again, there's our data argument set equal to mod data 2, and we'll use our summary function in order to look at our results. So here they are. You can see right here that the interaction term is actually not statistically significant. So ordinarily, if that's the case, we wouldn't spend a whole lot of time trying to probe the interaction. The regression slopes that you see right here are basically translated into simple effects tests. Essentially, we could look at this slope right here for negative life events as reflecting the difference in means on hope between the low and high negative life events groups for those individuals who are in the low grit group. So basically, remember that the low grit group was coded 0. This right here would be the difference between the low and high grit groups for individuals in the low negative life events group, which was coded 0. And again, we can use the probe interaction function, And you can see right here that now for the predictor I've got negative life events .ms for our binary variable, and then the moderator is grit.ms for that binary variable. So we'll go ahead and copy this and paste it in, take a quick look at it, and you can see the lines are not entirely parallel or not perfectly parallel, but they're very similar to, or very close to parallel, which is consistent with the notion of that there's no interaction that's taking place. And again, as we look at this regression slope right here, this is the same slope that we saw in our table above. So it's negative 1.54, which again is reflecting the difference between the low and high negative life events in groups for individuals who are in the low grit group. And then this right here is the difference between the low and high negative life events groups for individuals who are high in grit. So that is going to kind of wrap up this particular demonstration. I will note that in the text file that I have uploaded and also in the PowerPoint, there is a part 2 that I go over where I demonstrate a little bit more with moderated multiple regression involving factor variables, but I wanted to keep this fairly short and focus in on moderators that are binary, if you will. So at any rate, that concludes this demonstration, and I appreciate you watching.